Hello students, today we are going to discuss about the motion in one dimension. Class 11th physics, the first chapter, basically from where the physics starts as motion in one dimension. Till now we have studied about units and measurement and the dimensional formulas. So today we are going to start the first chapter of kinematics, and that is about motion in one dimension. So student, as we have discussed in the previous videos that our physics is divided into various branches, and one of the important branch that we study here in class 11th is mechanics. So mechanics is that branch of physics which deals with the objects which are either at rest or in motion. Okay, branch of physics which deals with objects at rest or in motion. Right, this is the branch of physics which deals with the objects at rest or in motion. Now the most important question that arises us here in front of us, what is rest and what is motion? Okay, what is rest and what is motion? Rest and motion are the two states. In the rest, the object is said to be at rest if it does not change its position with respect to surroundings and observer. Okay, I will just make it write the definition here in front of you, but I just want to let you understand the concept of rest. Okay, if an object does not change its position with respect to the observer who is watching. Now, as you are watching the video, if I just stand still, I do not change my position, then I will be considered at rest. You will be watching me that the person here is at rest because he is standing still like this. But suppose that I am just in motion, I am moving here randomly, then here, then what is happening? Actually you will be observing that the person here in the video is just moving. How will you come to know that the person is moving? Because you are having a common basic sense that has been developed over the years that the blackboard behind that person is obviously still, and because he is changing his position with respect to the blackboard comes under around my surroundings, and I am just putting my legs here or backward, right? Then you will just have a basic sense of understanding that the person is in motion. But let us think it of in a wider form. थोड़ा सा ब्रॉड चलते हैं अपन, थोड़ा सा इसके बारे में खुल करके सोचते हैं कि रेस्ट और मोशन होता क्या है. ओके, नाउ आई विल जस्ट टेक सम एग्जांपल्स. आई विल जस्ट अंडरस्टैंड विद द हेल्प ऑफ सम एग्जांपल्स concept of rest and motion. Okay, what is rest and what is motion? Okay, for that just let us take one example, very easy example. Suppose that you are going to school and your mother or your father, someone or your brother came to see you off, to make you bye-bye. Okay, and this is your bus stop and here you are present. Okay, and there is another person with you who came just to see you off. Suppose that he is your brother. Okay, this person is your brother, and this one is the bus, your school bus that has come to pick you up from the bus stop. And this school bus arrives at your stop, say at 8 a.m. in the morning. Okay, now what is happening? You just climb up in the bus. Okay, just go inside the bus and find a seat nearby your best buddy or is your best friend. You just go and sit beside him. He is already sitting here. You also go and sit beside him. Okay? Now after picking you up, your brother is still standing here for some another reason. And your bus reaches to some another position here. Okay? And suppose that it is 8:10 a.m. here. Now, you are still seated near your best buddy. Okay? And your brother is still standing here. A lot of thing has happened in the last 10 minutes. From 8 a.m. to 8:10 a.m. What has happened? Your school bus has moved a certain distance. From this point to this point, your bus has moved a distance. Like this. But the person who was standing at the bus stop, who just came to say bye-bye, is still standing there. Okay, he is still standing there and he is observing that at 8 a.m. my brother was standing besides me and at 8:10 a.m. my brother has moved a certain distance. So, you have just changed your position with respect to your brother. You were standing beside him and after 10 minutes you are at some distance apart from him. So you are basically in motion with respect to your brother. But the person who is sitting in the bus here, what he will observe? He will just say that at 8 a.m. you were sitting beside me, at 8:10 a.m. you are again sitting beside me. So, have you changed your position? No, you have not changed your position. We both were sitting beside each other, okay, and we have not changed our position. So, what is actually happening? None of us had changed the position. So, neither me nor you are in motion. According to this person, say I am just calling you as X. X is in motion. Okay, X is in motion. But according to the best buddy seated here, your position have not changed. Both of you are at rest. X is at rest. This your best friend will say that you are at rest. This your brother will say that you are in motion. So basically the concept of rest and motion is not absolute. It is not defined on the basis of only one person. It depends upon observer to observer. Right? One observer was your brother. According to that observer, you have changed your position from one point to another point. So he will just say that you are in motion. But according to this person, what's sitting besides you, you have not changed your position from the last 10 minutes. So what he will think? That you are at rest. This is the concept of rest and motion. Whether it is in everyday life or whether it is in physics. Okay, now look, I am standing here, this blackboard is here. Okay, so neither me nor the blackboard is changing the position. So according to me, the blackboard is at rest. But sometimes it happens with us that we are traveling in train or bus or by car, and the trees that are located in the fields outside, they just appear to go in backward direction. Okay, they just appear that they are traveling in the backward direction. But what is happening? We are moving in forward direction. We are just changing our position. According to some person who is standing at road, we are changing our position. The trees are not changing their position. We know that the trees have their roots which are fixed in the ground. They are not changing their position. So what is happening over there? Think. Actually what is happening over there? Because we are changing our position with respect to those trees. So the trees are appearing to be in motion. Because one of the person, means one is observer, one is the object. If either of the thing is in motion, then the motion will appear. If both the things are not changing their position, they are just either traveling at the same speed or are not traveling with some speed, they are just standing still, then the condition of rest will appear. Okay, this is the fundamental of the theory of rest and motion. Rest and motion theory is a relative theory. It always relates someone. Someone is observer. If you are changing your position with respect to observer, remember you are in motion. If you are not, you are at rest. That's the basic funda of rest and motion. So, in moving ahead with the concept of rest and motion, we need to discuss a theorem which is change of origin or shifting of origin. Okay, so let us make it understand to you. This is the coordinate axis we are having. This is x-axis, y-axis. Both the axes intersect at a point, and this point is known as origin. Origin is 0, 0. Okay? And suppose that a person is standing at origin. A person is standing here at origin. And one other person is standing here. And suppose that the coordinate of this person is 3, 4. What does this coordinate 3, 4 mean? Okay, let us see. The x coordinate of this person is 3. So what does it mean? That the distance from the origin to this point is 3 units. That is along x-axis. 3 units. Okay. The distance of this person along the y-axis is 4 units. Okay. Now, what is actually the distance of this person from this point? So, we just join it. Because this is 3 unit, this is 4 unit, what will be the distance? Either we can calculate it simply by Pythagoras theorem, or we can calculate it by distance formula. By Pythagoras theorem, suppose that I am calling this point as P, this as Q, this as R. Okay, so your OP becomes equals to under root OQ square plus PQ square. Now, OQ is 3, OQ is 3 units, this becomes 3 square, plus PQ is 4 units, plus 4 square. OP comes to be 9 plus 16 is equals to root 25. OP distance becomes 5 units. Okay, what is basically that? The distance between this observer and this person, O4 observer or origin and this P4 person is 5 units right now. Suddenly, the observer moves towards the person. He just starts moving and reaches at this point. Okay, suppose that what is this coordinate of this point is 1, 1. Now what he will think? He just will think that because he is the observer, that person was at a distance of 5 units from me at some point of time, but now the person has approached me. Okay, now the distance has reduced. If the distance has reduced, then some motion has appeared. That is relatively. Either that person has moved or I have moved. Now what is the distance between you and me? So now let us calculate. Okay, for that calculation, observer, either you can use the distance formula again, but I will just teach you the traditional method here. Ki this observer will call himself again at the origin, at O dash, and we will again draw a coordinate system parallel to x and y axis again. Okay, this is our x dash, this is our y dash. This is our new set of coordinate systems. Because this person observer has moved from this one to this point and the coordinate of this point is 1, 1. That means, look here very carefully, that means this distance is 1 unit this much distance is 1 unit, and this one distance is again 1 unit. Okay, already this distance was 3 unit. Now the observer has shifted to this point, so the remaining distance is 2 unit, and the remaining distance from this point to this point, which already was 4 unit, but because it has moved by 1 unit, so this distance will be left 3 unit. So the new set of the coordinates of the person will become 2, 3. That will become the new set of coordinates for that person. With respect to whom? Observer. With respect, already before, in the previous situation, the person was located at a point 3, 4 with reference to the observer. Don't think that you are standing somewhere on the first. Just take your imagination that you are in the universe. And in the universe there is no coordinate system. There is nothing outside reference that we can take. So what he will think? That person is at some distance. What is the distance? He just calculate the coordinates. Okay, with the help of some gadgets he might be having over there, and he calculates the coordinates of that person, and they comes to be 3, 4. And suddenly he finds that the coordinates of the person have changed to 2, 3. It either may be due to the motion of the observer or that of the person, but the coordinates have changed, because the coordinates can only change if there would have been some motion, right? Okay, it means there is some motion. So what will be the new distance between the point observer and P, person? That will be odd as P. Again you can use the Pythagoras theorem, or you can use the distance formula. If we use Pythagoras theorem, then this distance is 2 unit, this distance is 3 unit. So what will be odd as P? That will be 2 square plus 3 square. That will be 4 plus 9 is equals to root 13. And root 13 approx comes to be 3 point something units. The person who was already at a distance of 5 units, now is standing at a distance of root 13 units. It means the distance between the observer and the person has changed. It means that if the distance has changed, then the motion has occurred. And this theory is known as shifting of origin. This theory is known as shifting of origin. Okay, now I will tell you how to calculate the shifted origin coordinates. अगर अपन origin को shift कर देते हैं तो नए coordinates कैसे calculate किए जाते हैं? Let us have a view over that also. For that, let us assume that this is our coordinate system. This is our origin. This is x axis. This is y axis, and this is the position of a person P. And the coordinates of this point are x naught, y naught. Let us assume them. X naught, y naught. It means that this distance from the origin is x naught, and this distance from the origin is y naught. Right? If we shift the origin to this place, suppose that the coordinates are h, k, and the new coordinate drawn are like this. The new coordinates are drawn like this. If this coordinate is h, k, it means this distance is h unit and this distance is k unit. Right? Now already this distance was x naught unit. So this one h unit is left out. How much it is left? It is left as x naught minus h. And already this unit was y naught, and k distance we have separated. Now this distance left is y naught minus k. So what will be the coordinates of the new point? In the new system, what will be the coordinates of the point? They are going to be like x naught minus h, comma y naught minus k. Right? That will become the x coordinate and this will become the y coordinate. So this is how the origin shifting takes place, how the coordinates of the new point are defined. The importance of the coordinates is very much in the case of physics. When we are defining the position of any point, so we are basically talking about the coordinates of that point. That is the basic standard method, right? Otherwise, there have been some other methods like you are giving the reference of some pan shop, some trees, like that. But that coordinates always gives the standard position. Okay, so this is how we calculate the new methods, new coordinates in the changed origin. Okay, so let us see some more terms. Now we will be discussing some terms, important terms which are related with the concept of rest and motion. There are some important terms which will just let you understand the concept of rest and motion. By important word doesn't mean anything here, okay? Just don't think that these are important, means they will be appearing in some competition exam or your semester exams or whatever the exams. That important term here is actually referring to the importance in understanding the concept of rest and motion. Okay, so the first term we study is distance. What is actually distance is? Distance क्या होता है? Okay, and how it understands, how it helps us to understand the concept of rest and motion. So students, basically distance is the path length between 2 points. Path length between 2 points is known as distance. Oh, what is the meaning of the word path length? Right? So path length between 2 points. Suppose that this is point A, this is point B, and the coordinates of this point are x naught comma y naught, and the coordinates of this point are x1 comma y1. So what is actually the distance between these 2 points is known as the distance. Okay, if that they are joined by a straight line. But what if this is representing some town? Say this is representing some town, New Delhi, and this is representing some town, let's say in Mumbai. Okay. So, but when you are traveling from New Delhi to Mumbai, you are not going it by a straight road only. There are certain turns that we need to take. Now that is, we have to go like this. To avoid traffic, we had the national highway built like this, and then we are reaching at point B. Suppose that the national highway is built like this. So whatever actually the length you are traveling here, the path, the length of the path that is actually you are traveling, that is known as the distance. Now this is your distance. Okay, this will be the distance traveled by you, because we are talking about the concept of path length. Okay, so how much path you have traveled in traveling through 2 different points, 2 different cities, that refers to the distance. Distance is a length concept, so it is always measured in meters. Okay, because the length, okay, it is path length, so it is obviously being measured in the concept of meters. Okay, now we are talking about the second term. Second term is displacement. Displacement. What is displacement? So students, a displacement basically means the shortest distance between 2 points. Shortest distance between 2 points. Okay? Say here New Delhi to Mumbai. If I am not going by road, I am going it by air, and unless and until I don't like the riding of aeroplane, I will just travel it by the straight path. So always a straight path is the shortest distance between 2 points. Okay? Because if you are like enjoying the aeroplane ride by air ride, then you would travel like this, more like this. But if you just don't feel comfortable in aeroplane, what do you want? We should reach there as early as possible. Then we will go by a straight path. So generally the shortest distance between 2 points is known as displacement. So displacement is also measured in, because it is distance and distance is measured in meters, so displacement is also measured in meters. Okay, it is also measured in meters. Now, there is a difference between distance and displacement. Distance is a scalar quantity. For distance, we don't need to follow any direction sense, because we know where the path is leading us, whether it is going like this or whatever, we are going along that path. We are not following any particular direction. Displacement is a vector quantity. It is a vector quantity because we need to specify particular direction. सीधे चले जाइए, go straight, right? We are going to follow some direction, particular direction. It means we are assigning that quantity a particular direction, and when you assign direction to a quantity, then that quantity becomes vectors. Okay, that's the difference between distance and displacement.